Hello, everyone. Many thanks for this warm welcome. I'm very, very, very happy to be there. It's my first time at GFocus. I was expecting that for a long time. So I'm a full-stack developer working at Saagie, which is a small French startup which you probably never heard about. And today we're going to talk about Micro Frontend. So to start, we are going to look through the evolution of our applications architecture. And to do so, I thought it might be easier if we took an example that we all know about, the Java Petstore. So anytime, at the moment, it was launched by Sun, something around 2005. Any language it would have been written at this time, the pet shop application would have been a classic end-to-end monolith. And then, front-end development became a thing, and all of these fancy JavaScript framework that we all love appear. And so we moved to another type of architecture where we split our monolith into a front-end application and a separate back-end application. Then, microservices entered the game, and that's the moment where usually our back-end application was split into a set of microservices, each one being in charge of a specific part of the domain, and only this one. So in the pet shop example, it would have gave us the product service and the search service and the checkout service, for example. An interesting thing to notice there is the way our team organization is strongly tied to our architecture. So for example, when the application was a monolith, we usually were just one team, the pet shop team. Then, with the split between front-end and back-end, we usually split our team in two separated teams, the front-end team and the back-end team, with one being the customer of the other one, but not necessarily working strongly together, sometimes not even in the same offices or cities or country. And with the operation of microservices, usually the backend team has been split into very small teams. So for example, here we would have the product team and the search team and the checkout team. And that's the first benefit of microservices. Having small and specialized team means that they're going to do just one thing, but they're going to do it well. And usually, those micro teams are delivering faster than big ones used to. The second benefit from microservices is that it gives each team the freedom in their stack choices. So if, for example, the product team wants to work in Java and the search team wants to work in Kotlin, doesn't matter. Every team is able to go for the framework language/stack, which is the more relevant and the more comfortable for them. Microservices are also easier to deploy because when you want to deploy a new feature, you're just deploying the microservices which has been updated. You're not deploying the entire stack again. And for the same reasons, they are easier to scale because, well, you know which microservices will be the more requested. So you're just scaling this one and not the rest of the stack. So it looks like now that we've got this front and microservices separation, everything is finally at its place and completely optimized, but it's not. It's not for two reasons. The first one is that in this architecture, and although in the previous one, the front and back split, by the way, you ended up having a front-end monolith, which is just as hard to maintain and involved than your back-end monolith was. And the second reason it's not is because, okay, so you were having those split and strange customer relationship between your front-end team and your back-end team. And now you're having a front-end team and a set of small and more efficient teams which are going to deliver faster and faster, whereas in the same time, the front-end team stays alone. So that's not going to work perfectly, as you can guess. And that's the reason why it's time to move to the next step of architecture evolution, and that's Micro Frontend. So the core idea behind Micro Frontend is to consider the application as a composition of feature. So we keep, our microservices on the backend side. They're working great. no way to just remove it. And we're going to split the front-end team into into smaller teams. So we're going to have only small teams, but now they are going to work end to end. They are going to be in charge of their part of the business from the front end to the back end. That's a classic way of working for e-commerce companies, and not only, some of them are sharing about the way they're doing it, some don't. I strongly recommend you to have a look at the way they're doing it when they share about. So, if we're looking back at our pet shop example, a little bit optimized now, it would mean that, for example, you would have the product team, which is in charge of this page, the main page, and that's the only team in charge of this page. Okay, and this team is going to use components provided by other teams. So here, for example, the product team is going to use the checkout menu provided by the checkout team, and the search bar component provided by the search team. And the other core behind Micro Frontend, is that every team should be able to work with the stack they want, like we are doing for microservices, which means, in our example, that the product teams perhaps want to work in Angular, and the search team perhaps want to work with Vue, and the checkout team with React, and it's fine. It's going to work. So now we only have small teams. There is no big front-end teams anymore. We only have small and specialized teams, and that makes a big difference. Those teams are now customer-focused teams, which means they're going to be able to concentrate on providing the best user experience as possible on their very own domain. They don't have to care about what's happening otherwise in the application. They just can concentrate on their part of the business. And that makes a big difference. So we keep the benefit of having those small teams, but they are now customer-focused. We keep the benefits of having freedom in our stack choices, but now applied to front-end, which is quite a thing, right? Plus, your teams are now more autonomous in their development. Because, if something is broken on the search page, audited by the search team, it has no impact on the work of the product team, which is working on the product page. So each team can just continue to work as they were doing and wait for the other team to fix its bugs, for example. Plus, you're now more autonomous in the release of new features, because you don't have the front-end team to wait. Well, you don't have, the micro backend team to wait for the front-end team to integrate all that features they were delivering faster. It's now just one team which is delivering the feature end-to-end, so it's going to be easier for everyone. And making your application evolving is made easier this way, because you don't have to plan a refactoring and an entire move. You just can plan it piece by piece and do it step by step, and that's way more easier when you want to refactor something like a legacy application, for example. So now that we've seen the theory, let's move to a real-life study case, the Data Fabric. So Data Fabric is the name of the Saagie's product, the one I'm working on. It all started in 2015 with the manager. The manager is a kind of big data job orchestrator, so basically data engineers and data scientists can upload, run, pipeline their own jobs with all tools they are used to have, like R, Python, Spark, whatever. This one was released in July 2015, so it was written in AngularJS. Then came the governance, which is the tool I'm mostly working on, which is very different from the manager because this one is business people oriented. It's very, very, it's much more for example, chief data officer people and all that kind of people who wanted to look at the data lake and see how they can extract value from that. So the governance tool is helping them to document their data. This one was launched in March 2017, so it was written in Angular 4, to be precise. And a few months later came operations. And this application is very different from the two others because this one is not tied to a platform/data lake. This one is here to enhance the overall customer experience by providing a way to monitor platforms and data lakes. And at this point, we realized a few things. We realized that, first, we were having the need for other tools like operation to enhance the overall customer experience. That we needed to extract common services from the manager, which was, at first it was a monolith, so it was taking care of security, for example, which perfectly makes sense. But when you have several applications coming and all of them need security, you come at this point where you need to extract that into a separate application. And the third thing we realized is that we were having the need to display all of these applications into a single application. So, in October 2017, we started working on the version 2 of Data Fabric. And we decided to go for a Micro Frontend architecture, and we decided to merge our two teams, because we were not big enough to have a separated front-end and back-end teams on both products. So we merged the two teams. We make a big, big, big team with all developers. Well, not too big, actually, but well. And all people in those teams were going to work in micro teams on every product. So on the human side, it went smoothly. On the technical side, not that much. We started with something we call Layout, which was a JavaScript application launched in December 2017. Then we made another try with something we called Galaxy, written in React, launched in March 2018. And finally, we ended up with Layout-as-Lib, which is written in JavaScript 2, which is in production since July last year. And that's what we are going to talk about right now. So, first of all, to have an idea of what we were looking for this second version of Data Fabric. That's the version 2 we targeted. So you got a primary nav component, which is here to allow the user to move from platform-related applications to other platform-related applications, like governance and manager, for example. Then you got a second component, the top bar component, which is here to let the user move from non-related platform application to other non-related platform application. So, for example, between security and operations. Then you get a user menu. I think this one is quite obvious. And the main component of the page is going to be the application. So it could be, for example, the manager, written in AngularJS, or the governance, written in Angular. Before going into further technical details, I would like to say a word about design system, which is something not every developer is familiar with. Design system is absolutely mandatory in the case you are doing Micro Frontend, because there is no point to do Micro Frontend if you're not going to provide a unified user experience all over your applications. Design system is a kind of library for CSS, but also behaviors for all components that can be used in your applications. So that's very essential. That means you're going to have to work with UX people, and they are very nice, so you really should do. Ours is called Saagie-ui. It's public on NPM. It can be reused for commercial purposes, but feel free to have a look at it, just the way it's made. Perhaps you can get inspired for use. So, now let's move to the first try, Saagie-Layout. So Saagie-Layout was a composition of web components as described on the microfrontends.org website. Don't worry about the references. I'll give you all the links at the end. So it's completely the architecture we've seen previously with an aggregation of components. But this time, each component is going to be a web component. So every component we've seen previously, plus existing applications in AngularJS or in Angular, encapsulated into a web component. Quickly, if you're not familiar with web component, they rely on 4 specifications, which can be used on their own, but combined together allow the developer to first define your own very own custom elements by defining your own tag, whose style will be encapsulated, completely isolated from the rest of the application thanks to the shadow DOM. which is something very important when you're as good in CSS as I am. With markups that can go unused at first load, but be loaded later, and which have a consistent way of being declared thanks to ES modules. Declaring your own web component is very simple. You're going to create a JavaScript file, okay, and you're going to declare your component which extends the HTML element. And then you're going to have access to several methods through the API to manage the lifecycle of your component. So first you get the connected callback method, which is called every time the element is attached to the DOM. You get the disconnected callback method, which is called every time the element is detached from the DOM. And you get the attribute change callback method, which is probably the most important because that's the one which is going to be called every time the value of an attribute has been changed. In other words, that's the one which is going to be called each time you want to update your component with new values. And then something that is not in the specification, but that you will see quite often, usually we declare a random method to declare all the markup of your components. So that's where you're going to declare, for example, that this component has a div and then a link and a button, whatever. The reason why we're usually declaring this random method is because there is two moments where we want to declare this markup. It's at the first load on the constructor and when the attribute change callback method is called to update the component. So to avoid code duplication, we usually put all of that in the random method to keep things clean. Once you've done that, you just have to register your component by calling the custom elements API and defining your tag component and your tag file. Then, in your HTML page, it's quite simple to use your own component. You're going to, well, import it first. That seems obvious. And then you're going to declare it as you would do for any other component, like, you know, a div, link, whatever. But I suspect you expect your component to work on every browser, including old version of browsers. So you're probably going to need something like this polyfill. This one seems to be the most stable, reliable at the moment. But the good news is that the full specifications are now included into every modern web browser, which obviously does not include Edge. Well, the news is that they recently moved to the Chromium engine, so probably, I guess, this will not be necessary anymore. But that's things to come. So, how do you create a web component from an existing application? If we are looking at the manager application, the one written in AngularJS, we're going to create our component like we would do normally. And then in the random method, we're going to declare a div. And this div is going to have the ng-app and the ng-controller of our application as attributes. Here, for example, we need to pass parameters to subdirectives, so we also declare our subdirectives, and we're done. And that's even more easier with an Angular application because you already got this strong logic, strong component logic included. So in the data governance component, for example, we're just going to declare our top-level component. And that's all. We're done. So now if we look at the Saagie-Layout application, you know, so the run to rule them all, in the main HTML page of this application, we're going to import both our components. And then we're going to import our Saagie-ui library, you know, the design system we defined previously. And then we are going to declare our top-level component, which here is called the SLA board component. This one knows all the markup of the application. So it's going to declare the primary nav we've seen previously, the top bar we've seen, and then to know which applications to display in the main part of the page, it's going to call the getPage method. And this getPage method is going to look at the path to see which application has been requested by the user. Is it the manager? Is it the governance? And in function, it's going to send back the proper web component containing the application. And obviously, at the end, we define our component to the custom element registry, otherwise it won't work. So there were several benefits to this approach. First of all, it provides a very consistent user experience, meaning that it doesn't matter if you were on the governance application or on the manager application, you will always have the same look and feel for the overall menus. Plus, we would have been able to display several components on the same page if we wanted to. Doesn't happen in this try, but it could have been an option. And we were completely independent on the deployment side because Saagie-Layout was a separated application with its own life cycle, completely independent from governance and manager. Fine. But we didn't include other applications in this try because we quickly ran into several issues that were blocking for us. First of all, it's not a true single-page application at all. Actually, we were not just binding and unbinding components. We were binding and unbinding applications in two components. So when you were moving from manager to governance, it was reloading the application each time, and it was having very bad performances. That was due to the fact that each application is coming with its own version of the with its own router first, with its own version of Saagie-ui, with its own version of Babel, etc., etc. So that, first, is prone to conflicts, because obviously, if, for example, Saagie-Layout does not have the same version of Saagie-ui as the governance, that will not end up quite well. And then causes very, very bad performances, because those libraries were not binding and unbinding properly, especially unbinding properly. So it introduces a strong tie between our libraries in all of our application, meaning that if we want to upgrade the Saagie-ui version of the Saagie-Layout system, we have to upgrade the Saagie-ui version of every other application. Okay. It could have been a true single-page application if we put the time to unbinding those components properly, but actually it doesn't worth the time, effort, and energy it would have cost us. Plus, another issue is that those two applications are coming with their own router system, which is, as a lot of applications are doing those days, based on hash, meaning that to stay in a consistent state, Saagie-Layout has to know about every possible path of all of its sub-applications. So that's a strong coupling we don't really want to have, right? And last but not least, to be fully tested, Saagie-Layout implies to run the entire stack locally, because it has to be able to bind and unbind the data manager, which is neither something you really wanted to do when something like a data lake is involved, nor something you can actually do, because, for example, we're using FreeIPA in our stack, and FreeIPA doesn't run on OS X. So I can't run the on stack on my laptop. So considering this, we decided to keep the two oldest application into this version and to make another try for other applications, for newer applications. So we made a second try called Galaxy, which basically is the same as the first try. Instead of having web components, we're going to use React Fragments. So the components we've seen previously are now in React. You're not seeing the primary nav component because we are not in a platform-related application, but it's still there. It's exactly the same. And the plan was, in the second time, to use Tailor to be able to stream those components, those fragments, because that's a problem of Micro Frontend. Your components are maybe going to be served by different applications, and maybe they're not going to respond all at the same time. I will not spend a lot of time on this try, as it's essentially the same. Pros of this solution is that we would have the possibility to share not only behaviors and CSS, but directly small components all across our applications. So small React components like, I don't know, button, menu, field, whatever. And the other pros of this solution is that it would have given us the opportunity to centralize our routing system, meaning that sub-application would have been lightweight. And as you can guess, we quickly ran into several issues. So we stopped after the first try because we were still having this dependencies coupling problem. But it was even worse, because this time we have the same with React. So the thing is, if, I don't know, for example, the new security application wanted to use a React component which is not in the React version of the Galaxy application, it means that you would have to update the React version of Galaxy plus the React version of every other sub-applications in order to be able to use it into security. So that was really blocking for us, and that's the reason why we stopped after the first try. So for the third try, we decided to reverse the logic. And we moved the Saagie-Layout application from an application to a library. So it became Layout-as-Lib. We kept our web components that we made in the first try, and we moved them in a very pure and lightweight JavaScript library. And this library is published on a private NPM registry so that every other applications are able to install them the way they're doing with any other NPM libraries. So they continue working the same, and the library continues to do all the API calls needed to configure itself properly, and that's all. So how does it look like on the application side? Here, for example, I took the main page of governance, the Angular 4 application. And in the main HTML page, we are going to simply encapsulate the data governance component, you know, the one we've seen in the first try, the one we put in our web component. This time, we're going to encapsulate it with a Saagie-Layout component, which is going to be hide by default. And then, in the main TypeScript page of the application, first of all, we are going to look at the path to determine if we are in a legacy mode or not. If we are not in legacy mode, we are going to call the init method on the load layout data class, pass all parameters needed for the library to be displayed properly, with all the user rights, profiles, platform, etc. And then we're going to remove the hide attribute from the layout component. So it doesn't appear if the user wanted to have the legacy version of the application, and if we are on the new version, we're going to display the menu. On the library side, on the Layout-as-Lib library, the main page is very, very simple, very stupid. It's just going to declare all components we've seen previously, the primary nav, the top bar, etc. It's going to expose the load layout data class we've seen previously, and that's all. And this load layout data class is the one which is going to make all the API calls needed to configure the menu properly. So it's going to make, for example, it's going to call the load data method, which is going to make several calls: the load rights, the load profile, the load users, jobs data, sorry. And if we're looking at the load rights method, so this one is going to then set the list of platforms to the component with platforms that the user is allowed to see. And this set platforms method is going to call the layout component directly to say, OK, this attribute value has changed. Please update it with this new list of platform. This layout is a very simple web component, as we've seen previously. It has a connected callback method, as we've seen in the specifications. And in its attribute change callback, each time it's going to receive a new value for any of its attributes, like the platform list, for example. It's going to update every subcomponent it has declared. So it's going to use, OK, say that's the list of platforms, so I'm going to update the platform list, and that's all I need. But if it's about profile, for example, maybe I'm not going to show the governance, or maybe I'm not going to show security, etc. So it's going to call the layout component, and the other method it has is the init render method. And as you can see, it's not a render method. There is a very good reason why it's called init render, because even if it really looks like the markup we've seen in the web component of the first try, It's very, very, very different because this time, instead of having a getPage method that you can call to get the proper component to display, it has an inner HTML tag. And this inner HTML tag actually is our legacy application. You remember when we encapsulated our main component into the Saagie-Layout component? Well, here it is. So you don't want to accidentally call this method twice. You don't want to reload the entire application, do something very, very weird with your DOM. So that's the reason the method is called initRender. And for the same reason, before defining the layout component into the custom element registry, we're going to check if it's not already present. So this solution works way much better for us, even if it's not a single page application at all. And we can't anymore make an aggregation of components. And actually, it's fine because it's not our use case. There is no point, at least at the moment, that we need to provide components coming from security into governance or the other way. So we don't have this case. And we are not really aggregating small components together. We are more likely aggregating single-page applications together. And that's the moment where we're going to talk about page transitions. Page transitions are soft navigation or hard navigation. Soft navigation is what's happening when you're moving from a page owned by a team to a page owned by the same team. So for example, that's what's happening when you're moving from the domains page of governance to the dataset page of governance. So in this case, usually the framework is doing all the stuff needed to unbind and rebind proper components, and you don't reload the entire page. Angular is managing this for you. Everything is fine. Hard navigation, on the other side, is what's happening when you're moving from a page owned by a team to a page owned by another team. So for example, when you're moving from the manager application to the governance application. And in this case, you can hardly avoid to reload the entire page, you know? That's the problem of hard navigation. And that's our main use case, because basically we wanted the user to be able to move from manager to security to governance to operations, etc., etc. And those are separate applications. So yeah, it's not a single page application at all, and we can't aggregate components anymore, but that's fine. Okay, that's even more fine because this is way more faster, because obviously it's way more faster to just display a library or not than to load the sub-applications into another application and to unbind it and to load another application. That works way much better. And it was way much more easier to integrate. I think all tests included non-regression tests and delivery. It took me 1.5 days to put it in production. So really, really much easier. One downside of this approach is that you may end up with a smallly inconsistent user experience. If, for example, the Layout-as-Lib team has delivered a new version of the library with a new menu item. New application is coming, new menu item. Until the moment, in governance, until the moment I upgrade my own version of the Saagie-Layout-as-Lib library, I don't have this menu item displayed. Okay, but a very good point on that is that I'm completely independent on both my deployment side and my development side. Meaning that if this new item, the Saagie-Layout-as-Lib team has added, includes a bug, well, I'm not impacted on the government side, you know. I can, well, maybe I've discovered this bug because I've released a new version of governance, including this new version of the library. But I can simply roll back my version of the library. And I can wait for the Layout-as-Lib team to fix the bug and then move to another version again. So that was a big advantage for us. But it's still true that in case of breaking changes, that might happen, it implies to update each application on the new version of the Layout-as-Lib library at the same time. that's something we decided that we can go with, so fine. Plus, we solved the libraries conflict. Because now, before upgrading my version of the Layout-as-Lib library, I'm just going to look at the version of the Saagie-ui library it's using. And if it's not the same version as I'm using, I'm going to upgrade my version to fix any possible bugs, and then to upgrade my version of the library. And we're fine. And last but not least, as you understood, this solution can be completely run on its own. You don't need to have the entire stack running on your computer. Basically, what we are doing is that we're having a small fake project which runs small express servers which are mocking the APIs the Saagie-Layout-as-Lib library needed to call. So it's going to mock the load rights and the load data and jobs and the load profile API call we've seen previously. And I'll be able to fully test the application on my laptop without having the entire stack running. So, at the end, the micro teams organization worked really well for us. In 1 year, we've been able to deliver 4 new applications. And we've been able to start breaking this big manager guy into first we extracted the security application. And then we've been able to provide a new version, which is more relevant for the users, which is called project and jobs. So as we were saying in the first time of the presentation, when we were talking about Micro Frontend benefits, we didn't have to plan the entire refactor in one move. We were simply able to extract the security refactoring, then to extract the project and job refactoring. Manager has continued to live its own way during this time, and whoop, we've switched at the end of the year. So, quickly, before we end, some best practices. I think you understood it's quite important to think about your use case first. Are you going to make an aggregation of components, or are you going to make an aggregation of single-page application? In other words, are you going to have more soft navigation issues than hard navigation issues? That's probably, to me, the first thing you should have a look at before deciding which architecture or solutions you're going to opt for. Then take care of your design. As we've said previously, there is no point to make micro frontends without providing a consistent user experience. So you will probably need a design system. And you're going to load components which are not necessarily coming from the same application. So you may end up with little variation in terms of loading time. So think about things like skeletons, for example, which is a very cheap and very simple solution to put in place. You already know what skeletons is, because it's used in a lot of applications you're using on a day-to-day basis, like LinkedIn, Slack, Twitter, probably Spotify too, Gmail, etc. Skeletons is providing a shadow of the items you're going to see in the application during the moment it's loading. It gives us the opportunity to say to the user, OK, something is going on. We're currently loading your data. It's not available at the moment, but when it is, you will see that. Just one point with the skeletons. Be sure that the shadows you're providing are the same that the final menu will be providing. Otherwise, it's a little bit weird for the user. You can have a look at Optimistic UI too. Optimistic UI is kind of a philosophy, I would say. It's taking the approach to say, OK, most of the time, everything is going to be fine, and we're going to, I don't know, create this new file, or to send the data to the users. There will be no error, no kind of strange behaviors. So let's decide that everything will be fine, and that we first display the view when everything is fine. So here, the philosophy is to say, OK, we're just going to take care of what's going wrong when it's going wrong. And on the other side, everything is going fine. Let's send the good design. And then share resources, but not runtime. Even if you're going to use the same stack all over your application, which is the case for us, we're we decided to opt for React on all the applications of our stack, simply so that every developers can move from an application to another. We reorganized our small teams in function of roadmap emergencies or priorities. So even if you're going to use the same framework all over your stack, don't share resources. Don't rely on shared state, because that will end it up very, very badly. But feel free to share common resources. You probably have some API calls, some fonts, some images, other things that you can share between all your applications. Feel free to do so. So if you want to go further, you can have a look at the microfrontends.org website, which is the one we based our first try on. So this one described the web components approach we've seen in the first try. It's all by Michael Gears, who has gave an excellent talk at Web Rebels last year, if you want to have a look at it. There is also a repository linked to the website, and in this repository you will find two examples, one with web components and one with server-side rendering. Server-side rendering is definitely something you want to have a look at if you're going to make an aggregation of components. Then, small article, experiences using Micro Frontend at IKEA. This one is not going technical deeper enough to my taste, but that's easy to understand because, well, that's kind of their own recipe. But it's a very, very interesting article which gave you an idea of how you can apply Micro Frontend to as big team as you can have in a company like IKEA. Project Mosaic, it's a set of services and libraries for fragment aggregation, which has been open sourced by Zalando. Probably the most known project of services of this project is Taylor, that we talked about previously. And finally, you can also have a look at Single SPA, which is still another library to do this aggregation of single-page application into one application. So that's all for me. We have a little bit of time if you have questions. No question? Yeah.
I was wondering how big was each team, these micro teams, and what do you think is a good size for this team? Will it vary much?
OK, so the question is, which time are those micro teams, and what is the optimistic size for those teams? So it can go from usually 2 to 4 people. I don't think it's very, very relevant to have a biggest team because, well, it's not going to go faster. So usually should be fine with 3 to 4 people. I definitely not recommend to have small teams of 1. That could happen when you are in a startup with not that much money. And it's definitely not a good idea because it means that someone is having all the knowledge about this application. So don't let him or her take the plane, you know? Yeah, so I definitely would go for 3 to 4 people. Oh, and yeah, another point. The fact that every team should be able to deliver the feature end-to-end does not mean that you are going to force every people in the team to do end-to-end development. And that's a good reason for having 3 to 4 people in the team, because I have some of my colleagues who don't want to do front-end developments. So when we are in 3 to 4 teams, it's just fine. Let's do the back-end, I'm going to do the front-end, and we're going to join at the end, and everything will be fine. That's a good reason for me to have a 3 to 4 people team. Yeah, another question? OK, looks like we are done. Thank you very much.